Now we discuss how to recognize elasticity on a graph. What does a demand curve look like if it is relatively elastic? And what does a demand curve look like if it is relatively inelastic? Let's start by comparing a couple of demand curves. So I have a purple demand curve and a blue demand curve, right? Each equally valid demand curves. They follow the law of demand. They're each downward sloping, right? But they're different. D1, the purple curve, is steeper, and D2, the blue curve, is flatter. But still, both valid demand curves. So the question that we want to answer is, which of these two curves is more elastic than the other? Right? Which is relatively more elastic and which is relatively more inelastic? And notice we use the word relatively because in order to determine whether it's more elastic or inelastic, we got to have something to compare to, right? So right now we're just comparing D1 to D2. Which of these curves is more elastic than the other? So remember, price elasticity of demand is the percent change in quantity demanded divided by the percent change in price, right? And we said previously that if quantity changes a lot with a little price change, then we call that elastic. If quantity changes just a little bit with a price change, then we call that inelastic, right? So what I want us to do on this graph is to look at a price change, right? And we're going to look at exactly the same price change, and how it affects quantity demanded with the purple demand curve or with the blue demand curve. So we're going to look at a price change from here, this price, we'll call it P1, to here, this price, we'll call it P2. All right. The first assumption we're going to make is that my lines are horizontal. So I just pretend that's a horizontal line. Sorry about my drawing skills. So exactly the same price change for the purple curve and for the blue curve. Let's look at the difference in the quantity changes. So let me get my blue pen here. For the blue demand curve at P1, we have a quantity demanded here. That's our blue Q1. And at P2, if we follow that second price line out to the blue demand curve, we have a quantity demanded here, the blue quantity 2. Now, for our purple curve, exactly the same two prices. So at P1, we have a quantity demanded here at our purple Q1, and at P2, we have a quantity demanded here at our purple Q2, right? So what do we notice? With exactly the same price change, which curve shows a larger change, a more drastic change in quantity? The blue one does, right? So with the blue curve, we go from Q1 to Q2, blue Q1 to blue Q2. With the purple curve, we only go from purple Q1 to purple Q2, right? So we see with exactly the same price change that the blue demand curve has a resulting change in quantity demanded that is much more drastic than under the purple demand curve. What do we know from that? We can tell from that a flatter demand curve corresponds to more elastic demand. A steeper demand curve corresponds to more inelastic demand. Remember, inelastic is where your quantity has a smaller response to a price change. More elastic means your quantity has a larger response to a price change. So, if demand is relatively elastic, it means we're relatively sensitive to price changes, and our demand curve is relatively flatter. If demand is relatively inelastic, we're relatively insensitive to price changes, and our demand curve is relatively steeper. So, in an extreme case, we could have what's called perfectly inelastic demand, where our demand curve is perfectly vertical. It's as steep as it gets. The numerator for our elasticity is 0, right? Because if we see a price change, it doesn't matter how big a price change we see here, P0 to P1, it doesn't matter how big a price change, we see no change at all in quantity, right? People do not change their behavior when price changes. The closest we get to this in the real life is something like emergency medical care, right? So if your child has injured himself or herself and needs emergency medical care, you go to the emergency room, they give you a quote, they tell you the price. Do you argue because last week when you were in there with a different child, the price was lower? You might try, but ultimately, do you walk away because the price went up? No. It's your child, and they need emergency care. You get the care. Your quantity demanded of care does not change just because the price changed. You have very inelastic demand when it comes to something like emergency medical care. This curve is still relatively inelastic. It's still pretty steep, though it's not perfectly inelastic. So notice with a price change from P0 to P1, we have a pretty big price change, and the resulting quantity change is pretty small, right? So we have a small top and a big bottom to our fraction. That's going to give us a fraction that is less than 1. That's pretty inelastic, right? Next on the continuum, we have this demand curve, which is relatively elastic. It's pretty flat, particularly compared to the ones we've looked at before. It's pretty flat. Because it's so flat, we can see a price change that's pretty small results in a quantity change that's relatively large. So we have a big top and a small bottom to our elasticity fraction, which will give us a fraction, a resulting number that's greater than 1 or pretty elastic. Now, on the far other extreme, we come to a demand curve that is perfectly horizontal, that's flat. In this case, the denominator of our fraction, our elasticity fraction, is 0. Because we can have a price change that's very small and an extreme change in demand. Folks don't want it anymore at all if you change the price even just a little bit. Right, so they'll go from demanding as many as possible to demanding none. Or if the price went down a little bit, maybe they would go to demanding infinity, right? So your demand snaps really big in either direction depending on a tiny price change. So again, this is kind of tough to come up with an example in real life here. The example from the Materia and Coppock textbook is demand for a $10 bill. So if you think about demand as being your willingness to pay for something, how much are you willing to pay for a $10 bill? Well, generally $10, right? So as long as the price of the $10 bill is $10, sure, you'll buy some or not. It doesn't matter, right? But if I change the price of a $10 bill to $10.01, how many $10 bills do you want? All of a sudden, none. all of a sudden your demand for $10 bills has gone flat. You want 0 of them. Your quantity demanded, I should say, has gone to 0 because of a teeny tiny price change. But you're not going to pay $10.01 for a $10 bill. On the other hand, if I tell you I'm selling $10 bills for $9.99, your quantity demanded for these things is going to go through the roof. Again, a huge snap from one extreme to another in your quantity demanded based on just a tiny little price change. So again, we see an infinite elasticity. Elasticity is as big as possible, and we have a horizontal demand curve. So one of the things that we've talked about that affects your price elasticity of demand is time. How much time do I have to adjust? And so we would see demand for exactly the same product over time could go from perfectly inelastic. So your demand for medical care, for example, if it's an immediate need, if it's emergency medical care, you have perfectly inelastic demand for medical care. The price can change, but your quantity demanded right now for medical care does not change. What if we're, instead of talking about emergency care, we're talking about your child came home from school with a cold on Friday, right? You've got some symptoms that might be troubling. Maybe they've spiked a fever over the weekend, but you've got some time to wait. You can wait until Monday to take them to the doctor's office and not pay as much as you would if you went to emergency care. So your demand, if you're given a little more time, your demand for medical care is a little more elastic, right? Still pretty inelastic because you still do want to get your child seen for for whatever's going on, but certainly more elastic than an immediate need. And then give it even more time if we're just talking, you moved into a new town and you need to find a pediatrician just so that you have someone to go to for your annual well check. Now you have a much more elastic demand curve, D3. You've got more time to adjust, more time to feel out the different pediatricians in town, ask around to other moms, and find who's the best bang for your buck in terms of pediatricians, right? So medical care is a really good example of how your demand curve for exactly the same product may change depending on how much time we give you to seek out that product. But this is the case as well for things like gasoline or for any other product, that the more time you have to adjust, the more you can and will adjust, and so the flatter your demand curve gets over time. Now, one little word of warning. Elasticity and slope of the demand curve are related, but they are not the same. So we've just shown that the flatter a demand curve is, the more elastic it is, right? So the more elastic that demand is. So yes, a flatter curve means something about the slope of the curve, right? So the slope and the elasticity certainly are related. They are not the same. In fact, as long as we're talking about a linear demand curve, which is the only type of demand curve we will discuss in this course, the slope is the same at all points. This is the definition of a line from your algebra class. It always has the same slope. Y equals mx plus b. That m is the slope of your line no matter where you are on the line. The slope is always the same. That's the definition of a straight line. But, as we will see, elasticity is not the same everywhere along the line. Elasticity, in fact, decreases, gets more inelastic as we move down and right along the linear demand curve. We're going to look at an example of that in a second on a graph. But first, let's think about why this is the case. So think about how you calculate slope. Y minus y over x minus x, right? The actual values of x and y go into calculating the slope. You learned that in your algebra class. Now, elasticity is a little different. It's not just change in values that we use to calculate elasticity. It's change in percentages that we use to calculate elasticity. And remember, a percent change is always relative to something. It's relative to our midpoint as we're moving, right? That's the midpoint method. And so your midpoint, if you're up high on the demand curve, right, your midpoint is going to be some high number. If you're down low on the demand curve, your midpoint is going to be some low number, right? So even if you move from 5 to 4, that's a change of 1, but a percent change, it'll be 1 divided by 4.5, the midpoint. Versus down here, if you move from 1 to 0, I'm talking dollars here, right? So if you move from $1 to $0, again, just a change of 1, so the slope is the same, but the midpoint between 1 and 0 is 0.5. So now you'll have 1 divided by 0.5 versus 1 divided by 4.5. Different number. Different percentage change, right? And that's the sort of mathematical reason that the elasticity is different at different points along the same line, even though the slope is the same at every point along the same line. Don't worry too much about the details there. You can always work this out for yourself because you know the formula for elasticity. So, for example, on this line, if you were to do the math, moving from $5 to $4 and 0 lattes to 1 latte, the elasticity is negative 9.1. That's if you calculated the percent change in quantity, moving from 0 to 1, and the percent change in price, moving from 5 to 4, and did the math, you would get an elasticity of negative 9.1. If you keep moving, what if we go from $4 to $3 and from 1 latte to 2 lattes? If you did the same calculation, you'd find an elasticity of negative 2.3. Keep going, somewhere in the middle you would find the unitary elastic point where elasticity is negative 1, and then we become relatively inelastic as we move down the curve. This is going to be especially important when we talk about how, as a firm, you can use elasticity to help to increase your revenues, right? It's going to matter whether you're at the top of your demand curve or at the bottom of your demand curve when it comes to making business decisions and how your customers will respond to a change in price.